In this video, we will go over the surface area and volume for a prism. So volume. We already learned last week how to find the volume of a rectangular prism. So remember, the formula was length times width times height. So if we look at a length of 10 and a width of 6 and a height of 5, and we plug those in, and we have 10 feet times 6 feet times 5 feet, we get 300 cubic feet. Easy enough? Right. Well, if you look, the length and the width is actually, right, the base, the area of the base of this prism, right? So this is one of the bases. And so the area of the prism, right, length times width times the height, gives us a new formula. So now we have this formula, volume equals the area of base times height, where area of base, we'll see it as a capital B, and height will be H, and the height means the height of the prism. So this will work for not just rectangular prisms, but all prisms. So let's give it a try. Okay, so here we have a triangular prism. So the area of the base is going to be different because the base is not a rectangle, it's a triangle. And so the area of a triangle is 1/2 base times height. So in this, our base of the triangle is the B here, is 15. And the height of the triangle is 8 centimeters. So first, we're just finding the area of the base. So the area of the triangle base equals 15. Oops, I think I have it on the next page, actually. Let's go back. Try to save time. Oops. Nope, I don't. I thought I did. So, area of the base, which is a triangle, is going to be 15 centimeters times 8 centimeters. Which comes to 120 centimeters squared. Okay, and so that is that first part of our formula for the volume equals 120 centimeters squared times the height, and the height of the prism is 12 centimeters, and that's going to give us 1440 cubic centimeters. Okay, and so again, the height is not the height of the triangle. We already used that. This is the height of the pyramid. And when you have a right prism, the height is going to be the measurement of one of the lateral. These are all the same. All the lateral edges are 12 centimeters. And they're always going to be, all the lateral edges are always congruent. So when it's a right prism, then the lateral edge length is the height of the prism. All right. So how do you find the surface area of a triangular prism? Well, remember how to find the surface area for the regular prism? You would find the area of each face, and you add the surfaces, all the areas together, to get the total surface area. And there are 6 faces. So we find the front and the back, which are these two rectangles. They're congruent. They're the same. So we can find the area. 10 times 5, right, length times width, equals 50 times 2 is 100 square feet. Then we're going to find the left and the right. So the left and the right have the dimensions of 5 by 6. So 6 by 5 times 5 is 30. 30 times 2 is 60. Why are we timesing by 2? Because there are 2 faces that have the same area. And then our last 2 are the top and the bottom. Again, they are congruent. They have the same area. Those dimensions are 6 and 10. So 10 times 6 equals 60. 60 times 2 equals 120 square feet. And then what do? We add them all together. 100 plus 60 plus 120 equals 280 square feet. Okay, so what do you think we're going to do for the triangle? We're going to find the area of each face and add them together to get the surface area. But now we don't have 6 faces, we have 5. We have the 2 congruent triangle bases and 3 lateral faces. So the first one, again, so we're finding the, the area of each face. So we're going to find the triangle first. And the area formula for triangle is 1/2 base times height. Again, now this base and height is the base and height for the triangle. So we have a base and a height of 8 and 15. Okay, so 15 times 8 equals 60 centimeters. I'm sorry, 15 times 8 equals 120 times 1/2 is 60 centimeters square. But wait, we have 2 bases that have the same area. We have the bottom base here, or the front face, right base, and the back one. So these 2 triangles are congruent. So they're both 60 centimeters squared. So that brings us to 120 centimeters squared. So that's 2 faces down, right? 3 to go. So now we have to find the area of the 3 lateral faces. And we'll start here with number 1. And we're going to do this face. And the dimensions of this face are 12 and 13. So now we're finding the area of a rectangle. So 12 centimeters, this should be times. 13 centimeters equals 156 centimeters squared. Next one we're going to find is the area of the bottom one. And what are those dimensions for that rectangle? 15 centimeters and 16 centimeters. And we're just going to have to change this to multiplication here. So 12 centimeters times 15 centimeters, length times width equals 180 centimeters squared. One more lateral face, one over here. So what are the dimensions? Well, this side here is 9 centimeters, and remember, all these lateral edges are congruent. So for this one up here, it's going to be 12 centimeters. So 12 times 9 is 108 centimeters squared. So now we found the area of each of our faces, the 2 triangle bases and the 3 lateral faces. So we're going to add them all together. 120 centimeters squared plus 156 centimeters squared plus 180 centimeters squared plus 108 centimeters squared equals 564 centimeters squared. So the same rules that we used before, for any 3-dimensional figure, if you can find the area of each of its faces for all polyhedra and add them together, you get the total surface area. Now in Unit 2, we will learn a formula that can work for finding surface area for all prisms. We're not going to get into it now, but I wanted to present it for those of you who want a little bit of a challenge. So this formula is surface area equals 2 times capital B plus H times P. So the B means the area of the base, P equals the perimeter of the base, and H equals the height of the prism. So remember, the base for this particular one is the triangle. So you would find the area of the base, then you have to find the perimeter of the base, and you have to identify the height of the base. Plug those values into this formula right here and simplify, and you should be able to get the same answer, which is 564 centimeters square. So if you want a challenge, give it a try. If not, this is something you will work on Unit 2.